It sometimes feels like an epic battle,
Hmm.
against those tiny invaders.
Hmm.
So today we're going to do a deep dive
Okay.
into antibiotics,
Sound good?
specifically a class called cephalosporins.
Right?
They've been around for a while, but
Yeah.
they've evolved to fight back against this
Yeah, right.
growing threat of antibiotic resistance.
That's right. It's a constant arms race.
Yeah.
Bacteria, they adapt.
Right.
So as we develop new antibiotics,
Uh-huh.
they evolve ways to resist them.
Yeah.
It's a challenge, but it also drives some incredible innovation.
I can only imagine.
Yeah.
We've got some material here
Okay.
focused on third and fourth generation cephalosporins.
Right.
These are like the elite forces in our arsenal, right?
Yeah, you could say that.
What makes them so different from the earlier generations?
It's like you're dealing with a fortress.
Okay.
Earlier generations of cephalosporins,
Huh.
they were good at taking down the outer walls,
Gotcha.
effective against what we call gram-positive bacteria. But the third and fourth generations, they're equipped to get through the inner defenses,
Huh.
those tougher gram-negative bacteria.
Why are gram-negative bacteria so much harder to fight?
They've got that extra layer of protection,
Interesting.
that outer membrane.
Yeah.
It's like a shield.
Making it harder for antibiotics to actually penetrate.
Exactly.
So are these newer generations
Yeah.
always the best choice, or
That's a good question.
are there times when the earlier generations might be more appropriate?
It's not always about using the most powerful tool.
Makes sense.
Sometimes a more targeted approach is better,
Right.
and that can actually help minimize the risk of resistance developing.
To the newer drugs.
Exactly.
Before we get into the specifics of each generation,
Sure.
cephalosporins actually come from a fungus,
That's right.
like a microscopic battle between fungi.
Yeah, they're derived from a type of mold
Oh.
called acremonium.
Okay.
And the discovery was kind of an accident, actually,
Really?
back in the 1940s.
Mm-hmm.
A scientist noticed that this mold was inhibiting the growth of bacteria,
Oh, wow.
led to a whole new class of antibiotics.
That's incredible.
Yeah.
So how do they actually work?
They're actually similar in structure to penicillin,
Okay.
which you've probably heard of.
Yeah.
Both target the bacterial cell wall,
Mm-hmm.
essentially preventing it from forming properly.
So it can't really protect itself.
Right, and that leads to cell lysis,
Lysis.
which basically means the bacteria bursts open.
Are there any downsides to this mechanism of action?
Well, that's a good question.
Could it harm human cells?
Luckily, human cells don't have cell walls
Right.
like bacteria do.
Okay.
So cephalosporins are generally safe for us.
Okay, good.
But like any medication, there could be side effects.
Right.
And allergies are a concern for some people.
Of course.
Other-
Back to those third and fourth generations.
Right.
It sounds like they've stepped up their game in terms of effectiveness.
Yeah.
Is it just because they're stronger, or is there more to it?
It's not just brute force.
Okay.
These later generations, they have undergone chemical modifications
Okay.
to make them more precise.
Interesting and effective. So let's get into the specifics of those modifications then.
Yeah, let's do it.
It's like we're upgrading weapons to fight this more formidable enemy.
Exactly.
What kind of changes are we talking about?
So in the third generation,
Okay.
one key modification
Yeah.
is the addition of something called an aminothiazole ring.
Aminothiazole.
Yeah.
Okay.
It's like a key that helps the antibiotic unlock that outer membrane
Gotcha.
of the gram-negative bacteria.
So get in there.
Exactly.
Are they clutter?
And then there's something called the oxamino side chain,
Okay.
and it acts as a shield,
Interesting.
protecting the antibiotic from being broken down,
So the bacteria can't fight back.
right, by enzymes that some bacteria produce.
Okay.
These enzymes are called lactamases.
Malactomyces.
Yeah, it's a mouthful.
I can imagine.
They're like the bacteria's own defense mechanism.
So it's a constant back and forth.
It is.
Each side is trying to outsmart the other.
That's a good way to put it.
What about the fourth generation?
Yeah.
How do they take things up a notch?
They build upon those strategies.
Okay.
The fourth generation has what we call a quaternary ammonium group.
Okay.
You can think of it as like a booster,
Interesting.
enhancing penetration and activity against even more resistant strains.
They're even tougher to beat.
Exactly.
They also have improved resistance to those botulactomices.
You got it.
We know how they're modified.
Yeah.
So let's see who they're most effective against.
Let's do it.
It's time for the bacterial hit list.
Right.
What kind of bad guys are we dealing with?
Well, the third generation, for example,
Okay.
is effective against a range of gram-negative bacteria,
Mm-hmm.
including Enterobacteriaceae,
Okay.
Neisseria gonorrhoeae,
Wow.
the cause of gonorrhea,
Yeah.
Haemophilus influenza,
Okay.
and even some Pseudomonas species.
So those are some pretty nasty bacteria. You might recognize names like ceftriaxone,
Mm-hmm.
cyclotaxime,
Yeah.
ceftazidime.
Yep.
They're all third-generation cephalosporins.
They are.
So those are like the heavy hitters when you
Mhm.
need a powerful weapon
Right.
against a wide range of infections.
Right.
What about fourth generation?
Yeah.
What are their nemesis?
The fourth generation,
Uh-huh.
they're particularly valuable against some of the tougher foes,
Okay.
like Pseudomonas aeruginosa.
Pseudomonas aeruginosa.
Okay.
It's known for causing those stubborn infections,
Right.
especially in hospital settings.
Yeah.
They're also effective against Enterobacter
Okay.
and Citrobacter species,
Yeah.
which are often involved in those tricky hospital-acquired infections.
So we've got these bacterial bad guys
Right.
and our cephalosporin heroes.
Yep.
Sounds like a microscopic battle is happening in our bodies.
There is.
But how does this all play out in the real world?
Good question.
When would doctors actually use these powerful antibiotics? That's a great question.
Yeah.
Let's dive into some real-world scenarios
I'm ready.
where these third and fourth generation cephalosporins become crucial.
Okay, let's get into it.
Yeah.
Okay, so let's talk about those real-world scenarios.
Yeah.
I'm picturing a hospital setting
Mm-hmm.
with doctors dealing with some serious infections.
Right, let's start with the third generation cephalosporins.
Okay.
Think about those severe infections,
Uh-huh.
like meningitis,
Okay.
pneumonia,
Right.
even bloodstream infections.
Yeah.
These are situations where you need a broad-spectrum antibiotic,
Makes sense.
one that can act quickly.
And what about those cases where doctors aren't sure exactly which bacteria is causing the infection?
That happens a lot.
Do they just go with the third generation to be safe?
That's often the strategy, especially when time is critical.
Right.
They can always adjust the treatment later,
Okay.
once they identify the specific bacteria.
So they start broad and then they narrow it down. Third generation cephalosporins are also used to treat gonorrhea,
That's right.
which is a sexually transmitted infection.
Yes, it is.
So it sounds like the third generation is like the first responders
Yeah, I like that analogy.
of the antibiotic world,
Hmm.
ready to tackle a variety of threats.
Yeah. They're versatile.
But what about the fourth generation?
Okay.
When do those come into play?
When the situation calls for the big guns,
Okay.
we're talking about those really stubborn, multi-drug resistant bacteria that we often see in hospitals.
I'm picturing those superbugs.
Right.
We hear about those all the time.
Mm-hmm.
The ones that are resistant to pretty much everything.
They could be a real challenge.
Are fourth generation cephalosporins effective against them?
They're a valuable tool,
Okay.
especially against Pseudomonas infections,
Okay.
which can be incredibly difficult to treat.
Yeah.
And they're also used for a condition called febrile neutropenia.
Febrile neutropenia.
Yeah,
That sounds a little intimidating.
it can be.
What exactly is that?
It's a condition where patients have a weakened immune system,
Okay.
often due to things like chemotherapy.
Right.
Their white blood cell count is low,
Mm-hmm.
which makes them extremely vulnerable to infections.
So even a minor infection can become really serious.
Exactly, because their defenses are down.
So you need an antibiotic that can act fast
Right.
and has a broad spectrum of activity.
You got it.
Fourth generation cephalosporins are like the guardians then,
I like it.
protecting those vulnerable patients
Yeah,
from a whole army of potential invaders.
that's a great way to put it.
It's incredible how these antibiotics have evolved
Yeah.
into such powerful weapons against infections.
That's amazing what science can do.
But even with all these upgrades, are there any downsides?
There are always things to consider.
It seems like there's always a catch.
You're right. One of the biggest challenges is antibiotic resistance.
Yeah.
It's an ongoing issue.
Right.
And even with these newer drugs, bacteria are constantly evolving.
So it's a never-ending battle,
It is.
with both sides adapting and trying to outmaneuver each other.
That's a good way to put it.
There are these enzymes called extended-spectrum galactomases,
Right.
or ESBLs,
Mm-hmm.
and carbapenemases
Yeah.
that some bacteria produce.
Yeah. Those are
They
trouble.
can break down even our most powerful antibiotics.
That's right, making them ineffective.
So what can we do to slow down this resistance problem?
That's the million-dollar question.
We can't just keep making new antibiotics forever.
You're right. It's not a sustainable solution.
Right.
Responsible antibiotic use is crucial.
So choosing the right antibiotic
Mm-hmm.
for the right infection
Exactly.
and making sure patients take them as prescribed.
Absolutely. And there's another important aspect, the economic burden.
Oh, yeah.
of antibiotic resistance.
That's not something we often hear about.
It's a big issue.
How does resistance impact us economically?
Well, when infections become resistant to first-line treatments, we have to resort to more expensive options.
Right.
Newer antibiotics are more costly to develop and produce.
Yeah.
And they may require longer hospital stays
Oh, wow.
and additional treatments.
So there are ripple effects
There are.
that go beyond just the medical aspect.
Right.
It impacts healthcare systems and ultimately all of us as taxpayers.
Exactly. Antibiotic resistance is a complex issue
It is.
with far-reaching consequences.
You have to remember that.
And one more thing to keep in mind.
Okay.
Some people are allergic to penicillin.
Right.
And there's a chance of cross-reactivity with cephalosporins.
Okay, so that's something to watch out for.
Yeah, definitely.
So where does this leave us? We've explored the incredible world of cephalosporins from their humble fungal beginnings to their role as these frontline soldiers against infection. What's the key takeaway for our listeners?
Well, I think the main takeaway is that.
Yeah.
I think the main takeaway is that the development of new antibiotics is incredible.
Yeah.
But it's a race against these constantly evolving bacteria.
Right.
We can't just rely on new drugs.
Right.
We need to use the ones we have responsibly.
That makes sense.
And that means understanding how they work,
Okay.
knowing their strengths and their limitations,
Right.
and being mindful of the risks.
So it's a shared responsibility.
It is.
Doctors have to prescribe these antibiotics carefully, and then patients need to understand how important it is to take them exactly as directed.
Absolutely. And it goes beyond that.
Really?
Yeah, we all have a role to play
Okay.
in preventing antibiotic resistance.
How so?
Things like good hygiene,
Oh, yeah.
vaccinations,
Okay.
and avoiding unnecessary antibiotic use can make a huge difference.
So simple things that we can all do.
Exactly.
I'm also thinking about the research side of things.
Yeah.
The constant search for new antibiotics and strategies to combat resistance.
Right.
That must be such an exciting field to be in.
It is. It definitely keeps us on our toes.
Yeah, I bet.
Bacteria are incredibly adaptable.
Wow, we talked about that.
They always find new ways to kind of evade our defenses,
Wow.
but also incredibly rewarding
Yeah.
to know that our work is helping to save lives
Yeah.
and protect people from these microscopic threats.
This has been an incredible journey into
Yeah.
the world of cephalosporins.
Yeah.
It's highlighted this broader issue of antibiotic resistance, something we all need to be aware of and take seriously.
Absolutely. It's easy to forget about these microscopic battles,
Right.
but they have very real-world consequences.
Yeah, they do.
Understanding how these drugs work,
Uh-huh.
why resistance is a problem,
Right.
and how we can all contribute to the solution is so crucial.
We've only just scratched the surface of this topic,
We have.
but hopefully we've
Yeah.
given our listener plenty to think about.
I hope so.
And we even inspired them to learn more.
And if you're interested in delving deeper,
Yeah.
we'll include some resources in the show notes.
This has been a fascinating deep dive into the world of cephalosporins. Thank you so much for joining us
Thanks for having me.
and sharing your expertise.
It's been my pleasure.
It's been an eye-opening conversation.
Likewise.
And to our listeners,
Yeah.
thanks for diving in with us. Remember, knowledge is power.
It is.
And in this case, it could even help save lives.
That's right.
Until next time, stay curious.
You've been listening to the Learning Podcast, a production of metaNESTA. Remember, learning is a journey. One step, one insight, one skill at a time. We'll see you next time. Keep learning, stay curious, and as always, be awesome.